All right, you found the Algebra 2 quick review, and this is irrational and complex root theorems. So what these theorems do is allow you to anticipate additional roots when given a root. And the whole key is they always come in conjugates. So first one is an irrational root. It's got a square root of 7 irrational number. So we always know that if you get 1, then you also get its conjugate. All right, so what is the conjugate? Well, they form a difference of two squares. So if the first had a negative in the middle, its conjugate's going to have a positive in the middle. Okay, so x plus the square root of 7 would be another factor. They always come in conjugate pairs, always. So if I get one root with a radical, I know I'm going to get its conjugate with the radical. And the exact same thing happens when you have a complex number. So if 3i is a 0, okay, so really what produced a 3i? Well, it would have been the factor x minus 3i, right? And therefore you always know you get its conjugate, which would have been the factor would have been the factor x plus 3i, right? Exactly same. One's a positive, one's a negative in the middle. Right? They form a difference of two squares. A factor and its conjugate always form a difference of two squares. So what would be the 0 of this? Negative 3i. So if 3i is a 0, then negative 3i is also a 0. And that's going to help you when being able to graph and being able to factor any kind of polynomial that already contains a rational root. You know, it gets its conjugate, or it already contains a complex number. You know it gets its conjugate. And real quick, being I'm doing quick review, don't forget, if you were to multiply these out, x times x is x squared. Because it's a difference of two squares, the outers plus the inners always equal 0, and you don't have to mess with them. They always add up to 0. So don't forget, finish with the outer times the outer. You get a negative 9i squared. And don't forget, an I squared is always a negative 1. So this is an x squared plus 9, right? So those two together, they are the factors of an x squared plus 9. Okay, so irrational and complex root theorems. Remember, whenever you have an irrational root or a complex number root, you always get its conjugate. That's the key.